In episode 2 of MobiCast, John and Chris lead a conversation about transitioning legacy applications to Docker. Welcome to MobiCast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
So here we are on our second MobiCast. This is pretty good. The first one was fun and a learning experience. And so the second one, we hope to learn even more and have even more fun. So in order to make it more fun, I decided that this week's topic is going to be comedy. So we have to be funny today. You ready for that, Chris and Rich?
The pressure.
Yes, just kidding. So what we're going to talk about is what goes on inside of an organization when you decide to make the switch to Docker. Who usually makes that decision, what it's like when people make that decision, when it comes from the top down or the bottom up, and then what does the company and the team that decide to do it, what did they go through? So I just wanted to start with a question for Chris, because Chris, you're the one of the three of us that was the first to say, I'm going to give this a try. I'm going to learn Docker. So can you tell us about the company situation you were in, or if it was a personal project, or what got you into it, and how did that go?
Sure. So I had heard about Docker, in various circles and things that I read. I'd played around with it a little bit, but hadn't really had the opportunity to dive too deeply into it until I, about 3 years ago, 3 years ago, joined a company, and they had just started to transition to Docker, specifically to run their Amazon web loads. And so one of my very first tasks, day one of starting there, was to start doing that, start Dockerizing all of the services, all the microservices that we had running inside AWS. So it was very much get thrown into the deep end of the pool, ramp up very, very quickly, and figure out how to do this and what does it mean, and to start running into all these brand new concepts and really different ways of thinking.
So do you know who at that company, what their role is? Who was it that decided to make that decision in the first place? It sounded like it was already made before you joined them, but do you know where it came about?
It was. So again, at that point in time, I think we had about 4 services that were currently being deployed, and actually most of those were, I believe, all of those were actually running. I'm trying to think back now. I think all of those were running, and they were Dockerized at that point. I don't know. When that decision was made by whom. It was a relatively recent decision because I actually joined that team when it was early on. So when I signed my employment agreement, there was 4 developers on that team, on the engineering team. And by the time I left a year later, we were up to over 20. So pretty small team, and also not very experienced. So I believe it was pretty much ad hoc. We had a great engineering leader for that team that came from Amazon, Microsoft as well. But I think Docker was new to him as well. So I think they said it was, again, pretty much an ad hoc process where it was like, hey, we understand at a high level there's some great features here for Docker. Let's go ahead and get our toes wet and start playing around with it. Especially at that point in time, we still weren't really running production. We hadn't opened the doors, if you will, for the first version of the service. So that experimentation phase was still kind of non-critical. So when I came on board, basically these services were kind of hand tuned for Docker. Docker was installed by hand. Deploys were literally scripts to stop Docker, copy images, start Docker. I mean, it was really rudimentary, and so we took it from there.
Interesting. So you said that there was a strong engineering leader there that had come from Amazon and Microsoft. I mean, we don't know for sure, it sounds like, but it wouldn't be surprising if that was the person that said, well, let's try this out. Let's see if we can make good use of this.
I suspect so. It's just part of just overall just good engineering practices. So, whether it be things like logging or monitoring or just deployment, just kind of knowing that, hey, this is definitely a technology that warrants us a closer look, and so let's start start using it.
Right. It's so interesting to me because I'm just kind of wondering for a lot of companies how it makes its way in. So the first time I heard about it was it was probably 3 or 4 years ago. I went to a Ruby on Rails meetup in San Diego, their SD Ruby group, it's called. All the meetups in San Diego are called SD and then the name of the topic because people are not that creative about their meetup names. See, we're on the comedy still. And the person that stood up and talked about Docker was a pretty young person, somebody, early to mid 20s, and essentially trying to convince the group. And the group was, ranging from, I think I was mid 30s at the time. And the group ranged from probably mid 40s to several people that were just even still in college. So this person, had maybe a couple of years of software development experience professionally and stood up and said, hey, I found this cool thing called Docker, and here's some tools that you can use to use Docker in your Ruby development environment. And it's great because, all the benefits of Docker, but he was really focused on saying how it had changed his development processes. And he wasn't talking much about using it in production. And I think a lot of the sort of graybeards in the audience were kind of looking at it going, wow, that looks like a lot of overhead. You can't even get into your server to see what's going on without doing an extra level of shelling. You have to create a terminal to get into the Docker thing in order to see, the logs and see what's going on. And you also have to map these ports and do all this extra stuff that feels like a lot of work for when we could just be typing, Rails space S, and now we've got a server running on our machine. But I think, this guy was convinced and we all were kind of not convinced. So it's sort of interesting to see, to have had that be my first impression and then be proven totally wrong over the years, like completely wrong. Like that was the future and I just didn't see it at the time. But I bring it up because if that was the person in an organization that was fired up about Docker, and there were, people that had the bulk of their experience, their software development experience pre-Docker, I could see there being a lot of pushback.
Absolutely. And I think this is kind of true across the board with lots of new technologies. There's a lot of just people in general, resistance to change. And as much as we all kind of say we like to learn new things and whatnot, actually changing the way that we work and adopting these new technologies, a lot of times there's a lot of resistance there, right? Because it is different. It requires friction to adopt those things. So Docker itself, it is a huge paradigm shift in how you think about software and how it is developed, debugged, deployed, packaged. There's some pretty radical changes in the way that you work. And there is going to be this period of adoption where it just doesn't feel good. It's uncomfortable, it's messy, it's frustrating. But if you stick with it, you'll get over that and you will come to see appreciate the features that you do get from that, the benefits that you do get from that. And it gets a lot easier too, right? As you start to really assimilate those concepts and those paradigm shifts, you become more comfortable with that. So I've kind of gone through this now with like 3 separate engineering teams, kind of introducing them to Docker, switching us over from a non-Docker process to a Docker process. And it's been like the exact same adoption pattern each time, which has been very, very interesting, but also kind of now comforting for me to know as well, because I kind of know how the story, I know how the movie ends.
Right. So I do want to talk about what that pattern is, and maybe you can talk about it in terms of Kelsus and what you saw when you introduced Docker to Kelsus. But before we get there, I still want to talk about this idea of pushback a little bit, because in fact, when you joined Kelsus, it was in January of 2017. I think you got some pushback from me on Docker because I was still not convinced at the time. Do you remember any of our conversations about that?
I do remember you and I talking, and I believe that was like one of the first things that I noticed was like, oh man, we gotta fix this. We gotta get on Docker. We have to start using ECS. this is we got some work here to do. And I do remember you kind of expressing some reservations, if you will, about that. It's like, whoa, wait a minute.
Right.
Why do we need to change? Things are working just fine. What do you mean Docker? What do you mean ECS? What are you talking about? So, but I think, again, once you start like just kind of talking about, okay, well, let's talk about what it is, right? Like, why would we do this? Like, there's some really, some great benefits to doing this, and let's talk about that stuff. And you need to work through that. So and I think kind of what you're alluding to here too, like there's a couple different levels of buy-in that you have to get, right? Like you have to get buy-in at the benefit level, kind of at the business decision level, like kind of really understanding like, yeah, this is the right thing to do from just a business efficiency, operation standpoint. And then you need to get the buy-in from the people actually you're going to change the way that they work, right? So the developers, the engineers, you have to get buy-in there. So there's two levels of buy-in that you need to get.
Right. And I think one of the things that happened early on was that we were doing a deployment for some clients, and I had checked in early in the week and then checked in the middle of the week and then checked in at the end of the week. And I was like, are you serious? We're still deploying? Like, what? This should have taken a couple of hours. What are we doing? So what was happening during that time? And why did something that used to take a couple of hours take a week?
So now we're talking about, when we first adopted Docker, why the deployment process got longer before it got quicker. Exactly. Right.
Because still on that topic of pushback, and I guess now we're talking about pushback from the business level a little bit.
Mm-hmm. Yeah. And so like I said, that's that kind of cycle of adoption where it's, when you first start doing the switchover, there's some really big just paradigm shifts and changes in the way that you think about developing, testing, deploying, packaging the software that makes things uglier and messier in the short term. And there's a lot of concepts to ramp up on, and they're usually concepts that are pretty new for most people, or at least they haven't thought about them in a deeper way. And so that's kind of what we went through at Kelsys, was just that ramping up on various new things. Not only was it Docker and containerization, it was also just some of the additional engineering sophistication that went around that, right? So not only were we moving to Docker, but we were also kind of figuring out how to like automate our builds and automate our deployments first through bash scripts, and then actually start using a continuous integration system, which we weren't using. So there are definitely some new concepts, technologies, tools that we were using along the way that just required quite a bit of ramp up. A lot of there's pitfalls. There's the common stumbling blocks that we all go through, type thing. So yeah, there's an adoption period where it's messy and it takes longer, but it gets better.
Right. And also to bring you along for the ride, Rich, and anybody that's listening, part of what I'm getting at is that we had relied heavily on platforms as a service before Docker. So we were using things like Heroku or Amazon's Elastic Beanstalk to do our deployments. And they do take care of a lot of things that you need to think about when you use Docker and ECS and Amazon outside of the platform as a service arena. So they are doing stuff for you for free, and they don't do it in a way that lets you control that stuff. They just do it. When you're working with a team that doesn't have experience building web applications at scale, and the web applications that you're building are sort of guaranteed to not need scale, those still might be a good way to go. You still might, need to throw together some software real quick and just get it online somewhere without taking even the extra few hours to do anything other than deploy it and show it to people and say, does this look like where you want to go from here? But once you have serious software that is going to scale and that's going to require lots of different services, and lots of people working on it, then the platform as a service model where it's completely opinionated how your software is deployed, starts to fall over a little bit. Every new application is an entirely new set of machines, or an entirely new application in the like in Heroku, it's an entirely new application that you have to manage, and they're not connected to one another. You can't do reports across them. You can't look at your infrastructure all at once, and so many other problems. I mean, we can talk about the benefits of Docker in general, and that's not what the point is. The point is, coming from that to Docker feels a little daunting, and it's quite simply, it's more. There's more to it. There's more work you have to do. And I think I, as the person who was running Kelsys, was used to not having to do a lot of work to get a piece of software in front of clients. But the reality was that sort of right at the same time that Chris joined Kelsys, our clients were needing more. They were actually needing more than just a quick, almost toy application thrown up on a platform as a service. They were needing real applications with real operations and support and infrastructure that a lot of people worked on all together at once and had different deployment schedules, et cetera. Before we got into the pushback on Docker, Chris, you were about to talk about the pattern or the path that you've seen happen a few times. Do you want to talk about that a little bit?
Sure, absolutely. Definitely the first big issue that folks run into with Docker is just kind of this idea of like, what does it mean to be running inside of a container, and what are now the moving pieces as I'm developing things? So you kind of instantly right out of the gate, people end up running into the issue of, okay, I'm used to writing my code. I can run it. I may have some support for hot reloading, and I'll bring up my editor, change some lines of code, and expect that to be kind of instantly updated and just work. And that's one of the first use case scenarios that, like, right out of the box just doesn't work for developers. So hot reloading is definitely not something that is going to be straightforward, right out of the box. You can achieve those kinds of setups, but it takes there are some setup that you have to do to achieve that, and then also you have to realize like what it is that you're doing and some of the pros and cons of doing that. But for me, it's definitely been like, I think one of the hardest things for anyone that's adopting Docker to understand is just like containers, and like, what does that really mean? It's not just this running a program or running your software on a machine anymore. You're running it inside of a container, and a container is this very much this isolated bubble that really is, for the most part, isolated from everything else. It's like completely disparate, and that is just like this huge mental shift for developers, and that causes a lot of the initial struggle with adopting it.
I think one of the first things that I remember along those lines was, okay, I put my thing in a container, I ran it, and wait a minute, now my container is not running anymore. What happened? Why is it not running anymore? I thought I started it. And it's because the process inside the container had some kind of error, and it caused the container to shut down. And the logs are in the shutdown container, so I can't even see what happened, and I have no idea how to troubleshoot that scenario. And I think that it's pretty common for people's first experience with Docker, wouldn't you say?
Absolutely, because again, it kind of boils back down to the fact that you are running inside this container that's completely isolated from the rest of it. So unless you do something different in your setup to kind of like punch a hole into that barrier, it's not going to happen. And so, yeah, you have something that goes wrong inside your code that's running inside that container. It has an exception. It terminates, and it's just, that's it. And so you can get access to that stuff, but you have to do some extra steps, right? So it's like you have to go look and say, okay, what was that container that was running, and that's a special flag when kind of looking at Docker processes, containers. And then from that, you have to say, okay, I got to go use this logs command in Docker. And then that will then allow me to see a little bit more on like what happened, what went to standard out, standard error inside that container to kind of understand, why did my software fail? So, exactly. So you're now in this, it's like, so as a developer that's new to this that's like there's a lot of screaming and yelling and frustration, right? Because it's like, man, you've made my life a lot more difficult. Like, I can't believe like how crazy this is. But again, it's an adjustment, right? So it's something that's new. And yeah, there's a bit more hoops you have to jump through there because of that barrier of the container. But you have to keep in mind that like that's one of the great things about Docker is that it does create that barrier for you. That's what enables all these benefits of Docker. So you kind of have to take the good with the bad and just learn to adjust, right? And to kind of there's many strategies to mitigate these some of these downsides and these typical problem areas that developers have, and you can make your process a lot smoother. And that's what happens, right? A part of that adoption period is that you start learning. It's like, okay, yeah, like I can do my logs a little bit differently. Maybe I'll write them to the file system and allow that to be shared with my host. So now I actually can see what's going on inside the container without being inside the container and understanding how that works and why that might be okay for me to do.
I want to put a placeholder on that for us to talk about that a little bit later. The things that people learn when they're overcoming these sort of painful new boundaries. But before we talk about that, I want to go on. Okay, so you talked about phase one was understanding containers. So then what happens after that? What's phase two or what's the next step in the evolution?
Right. And so I think, they're not necessarily like these really nice discrete phases, right? Because that what we're calling phase one, that kind of like really understanding and grokking this idea of containers and that your software is running inside this protected box that really is not meant to be seen from the outside. That is like the overall encompassing thing that you have to get over and just really kind of get your head around that. And I kind of this is, I don't know if this is going back a little bit, but there's a movie called The Abyss by James Cameron, and in that movie some undersea I believe they're oil well drillers, and but they have there's a Navy SEALs mission that comes along with them because the Navy SEALs have some top secret project thing that they want to do as well. So they go down with them. And at one point in the movie, the Navy SEAL shows them this new technology they have where he takes the pet rat of one of the oil drilling employees and gives him this fluid for he puts him in this container of fluid, and the guy is kind of freaking out because like this is his pet and his pet's going to drown, and the rat is submerged in this fluid, and you can see it's just struggling. It's trying to get free. It looks like it's suffocating, but the Navy SEAL guy is saying no, this is like a special fluid. It's actually highly oxygenated, and the rat will be able to breathe. It just has to stop resisting it and just let it happen normally. And so gradually there's less and less resistance from the rat until finally it's breathing normally. And so technologies like this, that kind of that scene always comes back to me. It kind of feels like this breathing fluid analogy where, you kind of go through this. It's a very radically different way in thinking of things. It's so different that there's a lot of resistance and struggling with it. But, gradually you get more and more comfortable with it until it's like, okay, I got it. I understand this. This feels normal.
Gotcha. So if we can't talk about it in phases, and I still want to talk about the whole process a little bit, because I think where we've left off is developers are getting their heads around what this is, and they've maybe been kicking and screaming a little bit because it's changed their lives a little bit. So how did they start over, beyond, the analogy that you gave where it's like, well, just breathe. What is kind of the next thing that happens? Like what causes them to start realizing that they can breathe? What is the benefit that they start seeing? Or is it what happens next?
Right. So part of it is definitely just the whole experience, right? Of actually just like doing it. So like you said, like, hey, I've just Dockerized my software. I've run it inside a container. It immediately dies. I don't know what's going on. So now I got to figure out like, okay, how do I debug this? Like, how do I figure out what happens? Right. So now you start learning about like, oh, this is how I can go list the containers that ran inside Docker. And oh, here's this flag that show not only active containers, but containers that are no longer active, along with their exit codes. And this is how I can see what happened inside that container with this other Docker command. You start using techniques like, maybe I can, I'm still having problems figuring out what's going on. So I'm going to make it so that my container doesn't exit, right? I'm going to put like a sleep command in there that will keep that container running so it doesn't prematurely exit. And then, as you talked about before, you can now shell into your container as if it were just a whole nother machine, right? And so you can now SSH into your Docker container and now peek around inside the live container. And maybe it turns out like files that you thought were getting written to a certain place aren't getting written there, and they're missing, or maybe the way that your configuration was set up is not the way that you thought it was. So you can start debugging that way. And so you're learning more now about how that containerization works. You're learning some techniques to help you work with it. That leads to experimenting further and learning more about other various problems that you may be having, like, okay, hot reloading, like how can I do that? And so, people will go and do some Googling and some looking at some blog articles and say, okay, now I understand, like there's ways to do this. And so let me experiment with that. So I think it's this process that, of just like getting in there, rolling up your sleeves, doing the work. And as you kind of run into these various stumbling blocks, you get over each one of them individually, until the stumbling blocks that you come across become fewer and fewer and fewer.
Right. I think you're hitting on something that to me is one of the biggest benefits that I've seen from Kelsa switching to Docker. And it's the one that I tell other business people, especially business people that run software development teams or that have software development teams inside their businesses, that I tell them about most. Because it's one thing to save on infrastructure costs, and it's another thing to believe that you can get some benefits like not having to shut down your application to upgrade it, things like that. Those are all great, but especially for companies that don't operate at massive scale, I think this one thing is just mind blowing, and it's bananas how good it is. And it's that up until now. And this may just be me and it may just be my bias, but I feel like I've seen that software developers end up in kind of two camps. And there's the camp that writes code that makes the application follow the business rules. And there's the camp that knows what's really going on inside that application, knows how to run it. And, back in the days of Java, it was those people that could debug a class path issue. In the days of Ruby and Rails, it was the people that could figure out how to get through some sort of gem compilation problem or some sort of dependency problem. They understood what was going on the machine. And there was a kind of a divide between those two. And I think more people fall into the first camp where, as long as everything goes well, they can write code that makes stuff happen on a screen that reacts to what users are trying to do. But then when things get difficult, they need to go find the senior person or the person that's in that latter camp that can actually know what's going on in the machine. And I would say that Docker forces the people that are in that like I can only write code camp to deal with machines. They can't get around it. There's no let me just look at the logs and see what's wrong. Everything else is just me looking at this other screen and typing in the commands that it tells me to. Like, they have to actually understand that ports are getting mapped, and they have to understand that a machine is starting and stopping when a process is running. And they just have to, like I said, they may have to shell into that for that container, and know more about it than they did before. And the thing is, if you can learn how to code and you can get good at that, there's nothing that prevents you from learning about how machines work and how your code runs on machines. It's almost, I think it happens almost out of a certain kind of a laziness or lack of interest. And Docker is like, nope, You don't get to be lazy anymore. You don't get to not be interested in this anymore. You have to learn this. And so then all of a sudden your whole team is better. They can all do stuff that they didn't used to be able to do anymore. And I could be overselling this, but is that what you've seen as well, Chris?
Yeah, absolutely. I mean, Docker containers in general, you're virtualizing the machine, right? So you have various of the subsystems that are being virtualized. So whether it be networking or input, I/O devices, storage, all these things come to the forefront now with Docker, right? Like before, like if you're just writing in a dynamic language, such as like Python or JavaScript or whatnot, like there's no real necessity. Like you can get, like as you were talking about, you can get by with writing software, with really not really understanding how a computer works. Like you really can't, right. Which is kind of like an unfortunate thing, right? And like I think kind of as you alluded to, there's certain folks out there where they're okay with that, like not having to know about that stuff, right? They can write some code, and there's going to be a lot of stuff that's mysterious to them, but they can get by with their job without really knowing that stuff.
Right.
With Docker, sorry, it's not going to happen. You're gonna have to know about networking. You're gonna have to know about storage. You're gonna have to start thinking about like different types of file systems, and that's just kind of the way it is. And so, and it because of that, it does make you a better developer, right? Because now you understand more about how the computer actually works, and those kinds of principles and bits of knowledge are going to be useful for other things. So now someone that maybe they hadn't really done anything with, cloud type things, now maybe like things like DNS start making a lot more sense to them. And so they can go use something like Route 53 and like they understand that. It might even, definitely SSHing into a machine, over a VPN or something like that. That becomes much more approachable, and whatnot. So, absolutely makes sense.
Exactly. So when I was upset that a deployment was taking a week that should have taken a couple of hours, maybe a better response would have been, well, guess what? The developers that are taking a week it's taking this long because they're learning DNS, they're learning file systems, they're learning networking, they're learning all these things that they just didn't know before now. And that's why it's going to take a week or longer to get them up to speed. And then now they do. And it's like, oh my goodness, the team is so much more capable. So in the process of, okay, we're taking on Docker, we're learning this, we're doing it. We've sort of been focused for this whole first part of the conversation on what happens to developers inside the organization that decides to take this on. And that is kind of the hardest place. It's the place where there's the most pushback and the most pain. But I think, it's not everything. Hopefully you're never stuck 100% in development. You eventually put some software in staging environments and let other people see it, or you test it in some testing environment, or you put it in production and give it to the world. So let's talk about some of the things that happen after development and what it's like for those things.
So, this is definitely one of the huge features of Docker is that when you Dockerize your code, you're basically packaging it up as an image. That image is basically a description of how to go start one of these containers with your software and the configuration and the operating system and all the support it needs in order to run. And one of the big promises of Docker is that if it runs inside Docker on your machine, it's going to run inside Docker on someone else's machine, right? It's fully self-describing. There really shouldn't be anything else that someone needs to do. So having this interoperability, this ease of passing these things around so that anyone can come up to speed with it, is a huge benefit. So even still just working locally, just being able to have another developer, someone else on your team to be able to sync up with your code, have that Docker image be built, and then run the code without really having to do anything, is a pretty huge win. I know in the past I've been on teams where before Docker was around, it might take you 2 or 3 days to get your development environment up and running in order for you to actually run the software that you're meant to be building. So you have to go install compilers and various libraries and sometimes device drivers, and you have to go get these dependencies, and you have to have these credentials, and there'll be a big long wiki post telling you how to do all this stuff. So with Docker, that's really kind of done as part of the Dockerization process. And after that, no one else has to deal with it. So you get the benefit of now passing these images around your teammates in local development, but then also when you want to deploy to other various machines, whether they be on-prem or in the cloud, in your staging environments or production environments, kind of the same principle applies, right? You've built up this pre-packaged image of your software, and as long as you have Docker support running in the environment that you want it to be deployed in, you have utmost confidence that you're going to be good to go. And it's literally just a matter of starting a new container based on that image.
So I want to stop you before we get too much into bringing it up on staging or production. There was something that you said that I kind of got stuck on, and I was wondering if it made sense to you, Rich. So Chris, you said it's fully self-describing, and as soon as you said that, I was like, oh, that sounds difficult to understand. Rich, did you know what he meant when he said that it was fully self-describing?
Yeah, I got out of it that it reads that config file and just does everything it needs to do internally. Is that right?
Okay.
Yeah.
Yeah, that is pretty much right. So the configuration file says, here's everything I need in order to make myself. And I can make myself anywhere. I don't care if I'm making myself in saltwater or freshwater or in the mountains or in the valley. I can make myself. And that is exactly the kind of point that was exactly the point that Chris was about to make. So I've made myself in a development environment on somebody's MacBook Pro, and now continue from there, Chris.
Yeah, so like in a typical workflow, developers are working on software. They're developing locally on their machines. They go through their development process, testing, verification. Now they're like, okay, I'm ready. I want to have this be deployed. Deployments become so much simpler now with Docker because what you're really deploying is literally just that image. You don't have to go worry about like, okay, now I have to make sure I have the right operating system running on my instance that's running in the cloud, or I need to make sure that it has like this compiler or that compiler installed on it, or it has this library or that library. All that stuff goes out the window. The only thing you need on that host machine in your cloud environment is essentially Docker. So as long as Docker is running on that, you can now very easily, you can script it. Can be completely automated if you want to just say, hey, Docker, run this image. And containers, because the surface area that they virtualize is smaller than a full up virtual machine, containers can start up very, very quickly. So before in the past, where we might be used to deployments taking minutes, 10 minutes sometimes, depending on what you're doing, when now with Docker, deployments might take seconds, 5 seconds, 10 seconds, if that, type thing. So much, much faster.
So at the first company that you were working with, as you were going through this process, were you spinning up EC2 instances on AWS? You're spinning up real sort of physical machines, like they're actually virtual machines, I guess, but for all intents and purposes, they're full machines. Were you spinning one of those up, logging into it, and then putting a container on it manually, and then running that container, and that was your staging or your production environment?
Yeah, for all intents and purposes. So it was pretty rudimentary, right? Like that was actually one of the things. Even just take away Docker out of the equation, just the fact that you have like these dedicated machines, not behind load balancers, using elastic IPs to run actual like the production software. So definitely rudimentary, and a lot of work there to get everything kind of more in a really production worthy environment. So yeah, starting off with these were just dedicated EC2s for each one of the services. The Docker daemon had been hand installed and was running there. So deployment was literally, stop the running container, pull the new image, and then start the container with the new image type thing. And so quickly got away from that, saying, "Hey, this is really not very scalable. It's not very available. We need to do some. There's a lot of improvement here." So,
how do you think you ended up there? That seems, because it sort of seems like for people that have a lot of experience developing and deploying software, was it an accident that you ended up in that situation where you were sort of hand managing containers, or was it, we know this is going to be painful for a little bit, we know this is not the right way to do it, but at least it's a step in the right direction towards eventual automated container management?
So it's the life cycle of adoption, and it's also just like where the technology was too, right? So this is, that process was kind of like solidified in mid 2015, and at that time, you ask for a count of hands, like who knows about Docker? And you have 100 people in the room. There's not going to be many people going to be raising their hands that even know what Docker is, right? Let alone like what it does and like why you would use it. So this was still pretty early days, for Docker. A lot of the tooling around it that we enjoy today didn't exist back then. So that was part of the function. Same thing with like Amazon. So Amazon now has its orchestration environment for Docker called EC2 Container Services, ECS, which is a great system. Makes it really easy to run your Docker images across a fleet of EC2 nodes. That in mid 2015, it may not have existed, or if it did, it was just getting started, right? And it was pretty cumbersome. So there weren't a lot of great options, right? So that's part of the reason for that. The other part of the reason, and like this is super natural for so many companies, is that company was very early on, right? Like I said, it was a team of 4 developers, and it had recently done its, I believe it had recently done its B round, and was really starting to ramp up. But it was early days, so it's a small early stage startup with a small engineering team. Got to be like, it's all about the MVP and pragmatism and getting stuff done. And so that kind of stuff gets rolled out in an incremental fashion, right? You build your sophistication incrementally. It's not boiling the ocean from day one. It's instead, just making progress each day. And then as you get bigger and get more people on board, then you can start doing the things that you want to do.
Sure. Okay, that makes sense. I can imagine that it might have been a little difficult for people that had experience, say, with platforms as a service to deal with the fact that they're touching machines and hand managing containers when they, may have just said, get up. That's not quite the right command, but get pushed to this production repository, and then everything kind of automatically happens after that with their platform as a service.
Yeah, absolutely. Like the platforms as a service, they were great. They fulfilled a need where it was like it was hands off for the developer, right? You really didn't have to know anything about the cloud, right? Like you were in the cloud for free, right? All you had to do was just like, it was magic, right? It was mystery, and like you really didn't have to know anything about that magic and mystery. You really didn't care, right? All that you knew is like after 10 minutes, your application was up and running, right? And it's like, okay, cool. I'm a cloud expert. It's like, no, not really. But
so because, and I think 2015 was like kind of peak platform as a service. So, and because of that, I think maybe there are a lot of people out there that are coming to Docker and coming to containers wanting that. And then I think that there's just a glut of companies out there right now, quite literally trying to provide exactly that. So, so that you can be Dockerized and containerized in name only. One of the ones that occurs to me off the top of my head is Containership. Write your code, tell us where your code is, and we will Dockerize. We'll put it in containers, and we'll put it on click the checkbox for which cloud you want it on. Mm-hmm. Thoughts about some of those? would it be better to do, I guess, here's a question. Would it be better to do that or stay in a platform as a service? If kind of going all in and learning Docker and using something more sophisticated like Kubernetes or ECS is not an option?
Yeah, I mean, I think it's all these solutions exist out there because there's various slices of the market where they make sense. So I think it really boils down to, what your level of sophistication is, like what your capabilities are, what is important to you as a business. Like it may be as a business, like technology is just really not too terribly important to you. It's just something that you need to do in order to have your business running. And you may not have a huge tech team, or you may not care about that. You may not have like huge scalability requirements. And it may be okay for you to overpay on like a platform as a service option, because going with a better, in air quotes, technical solution that may cost half as much may save you $500 a month, but it might cost you, $100,000 to save that $500 a month, right? To build out the technology. Right, and that may not be your core competency, right? That may not make you, better in the marketplace for your business to compete. So it just really, I think it just kind of depends, on what your environment is, what your goals are, what you need to do. But there'll definitely be, there's always going to be spots in there for it's so the technology landscape is changing so quickly. It's so dizzying. I mean, just Amazon alone, they're launching. It's kind of crazy how many new I think they're up to like 130 services on their console page now, and it was like maybe like 10 like 4 years ago. And so they're literally launching like brand new services like on every month, several of these things. And so just keeping up with the innovation that's happening is very difficult for the experts. So you now extend that out to just like the entire marketplace in general, and everyone that needs to have something running in the cloud. It's like, it's super daunting. So there's huge opportunities out there for companies to mitigate that rapid pace of innovation to make it digestible and consumable by other folks, right? So there's going to be opportunities there for sure.
Right. You reminded me as you were talking about all the things that have been added to AWS, you reminded me of Kelsys's adoption of Docker and containers. And it's really been very much married to our adoption of AWS as a whole. So, I think we started with just using a few AWS services here and there. Oh, let's grab a EC2 machine to do something with. Or, RDS, their database management system is so good that let's just use that for all of our databases from now on. And then, after EC2 and RDS, then we looked at Elastic Beanstalk, and it was a great thing for a while. But now with containerization and Docker and the proliferation of AWS services, I think we must be using, of that list of 100 some, we must be using 30 or 40. And so it's really married to AWS. And I wonder if I imagine for companies that are tied into the Google Cloud or the Microsoft Cloud, if they're going through the same thing, that taking on containerization really means getting in deep with the cloud provider and all the services that it offers, and that it may not make much sense to try to not, to try to be cloud agnostic.
Yeah, this has kind of been an age-old issue that's been teams grapple with, and they have for the last 5 years, right? It's like, do you lock yourself in to your cloud vendor, right? By integrating in with the stuff that's specific just for them. And, I think someone like a provider like Amazon that is the undisputed leader in the space and cloud services, the amount of research and development they're throwing at this and the innovation that they are developing, the ease of use you get, the efficiency of scale, the better cost dynamics by using and integrating with these services, it makes it much harder to justify like keeping yourself agnostic, right? To say, oh, I'm going to pick up my stuff and go somewhere else. I'm going to go to Azure. I'm going to go to Google Cloud. So I think, at some point there's some tipping point where you're using a minimal amount of cloud services, and you can have the abstraction layers on them, right? So that you can say, yeah, I'm portable and I can pick my stuff up and go somewhere else. But there's a tipping point where you kind of just say, you know what, I'm all in now. And this is now my provider. And honestly, from a business perspective, that's what all these cloud providers are doing, right? That's why they are building these new services. That's why each one of these services is building on the previous services that have been developed, right? The synergy, the integration in with them, so they become more powerful the more that you use, right? They're tendrils. They don't want you to leave. They want you to be locked in, right?
Yeah,
so,
exactly.
It's great benefits to users, right? Because you're getting a much more powerful platform to work on, and it makes you much more capable, and it's more cost effective and just easier to work with. But it's causing some pretty severe lock-in for you as well.
Right. And I would say, I think the advice that I would give to people that are looking at moving into Docker and containerization is pick a cloud, just pick one. If you try not to, it will make the transition more difficult. And then once you do pick one, you'll find that that you'll be using more services within that cloud provider than maybe you had before you decided to do Docker and containerization. So it's a natural, unfortunately, the decision to go with the cloud and the decision to go with Docker and containerization is going to push you over that tipping point and get you locked into whichever cloud you do pick.
Yeah, indeed. And the truth is that usually, especially if you're at that kind of the workloads and the levels of scale when you're adopting stuff like that, you're not there at that level where it even from a cost standpoint makes sense to think about, oh, should I be running myself on-prem? Once you actually get to the point, if you get successful enough and you have enough traffic, where it's okay, now I'm really overspending by using a cloud provider, and I want to go look at doing on-prem. At that point, great, because you're so successful. You've obviously got a lot of resources, and you can now you can go do that, right? You can go spend the R&D to say, okay, now we're going to get off of this, and so instead of using ECS, we're going to go to Kubernetes, and that'll be our orchestrator, and we'll run it ourselves inside our own data center on bare metal.
Right.
But at that point, if your bill's $300,000 a month on Amazon, then that's a good problem to have.
Yes. That can be our conclusion for today. So at the end of the Docker containerization choice lifecycle lies a good problem where you're making $300,000 or you're spending $300,000 a month on your AWS system, and you decide to move it in on-prem. But the bigger conclusion is I think that as we've seen, it can be painful, but the pain is the pain that associated with learning, and not necessarily pain that's just for pain's sake.
Absolutely. And I will say that the level of pain today to learn Docker is a lot less than the level of pain 3 years ago. It's so much easier today, right? So it's gotten so much more sophisticated. There's so much more tooling around it. There's so much more of an ecosystem and information. And it's even easier to adopt it today. So even though there's still challenges and there's going to be that friction, it's a lot less so.
Right on. Well, let's wrap it up. Thanks, Chris. Thanks, Rich.
Thanks, guys. Yeah, thank you.